Today's demonstration is called making glass. And what I have here is I have a meeker burner, I have a ring stand, I have an iron ring, I have a clay triangle, and I'll get a shot of this. Inside my crucible, I have 3 powders, which I haven't mixed yet, so I'm going to go ahead and we'll use the camera up above and we'll take a look at it from above. I have 6.5 grams of lead 2 oxide in here, which is kind of an orange. I have 3.5 grams of boric acid, and I have half a gram of zinc oxide. And what we're going to do is we're going to heat this up while I show you some of my previous work, so that we can talk about what the end result looks like, and then today I'll add some manganese contaminant to this, and then we'll see if the manganese has potential for being a colorant for some glass. So we're really making leaded glass here. All right, can you get a good shot of that before I start to heat it? Okay. One thing. One stir rod. Okay. So I'm going to go ahead and light the burner. All right, that's pretty good. Okay. Now, if my students are like your students, which I imagine they are, I probably have 1 in 100 who wants to be a chemist, and the other 99 aren't quite sure why they're in my classes. So I try to relate as much as possible everyday life to what we're doing in chemistry. And chemistry's all around them. They're just not aware of where that chemistry occurs. And I have a lot of students who are very artistic and who are very into art. And so when we talk about making glass, that's something that's an automatic hook for them. So I have 5 samples up here. I have some chromium glass, which is in this test tube. Can you get a good shot of that? Okay. And I have some cobalt glass, which is in this second one. And I have some copper contaminated glass in the third one. And in the fourth one, I have some iron contaminated glass. And in the fifth one, I just have the plain glass without any contaminants in it whatsoever. And we're going to go ahead and get a little closer view of this, because it's actually much nicer looking when it's out of the test tube. Okay. So can we get a close-up of this? Okay. So there's my chromium glass, and you can see that it's very shiny. And that's a characteristic of leaded glass, is that it's very, very shiny. And here's my cobalt. Got a shot of that? Okay. Get that off the side. Here's my copper, which happens to be a personal favorite of mine, because I happen to like blues. And this is a really nice blue-green or turquoise. Okay. And then my iron. Is right here. And again, you see the nice shine that it has. And the last one is the plain glass. And how's that? Good shot of that? All right. Okay. It looks like my molten glass is almost done. So I have a small test tube of manganese 2 sulfate, which I don't know if you can see the color, but maybe if I hold it up against my blue part on my lab coat, you can see that it has kind of a pink tint to it. All right. It's not really white. It has more of a pink tint to it. All right. And I'm going to take a small amount of that, and I'm going to add it to my plain glass. Looking down on this, you can see that the glass is melted, and it's, if I take the crucible tongs and give it a little shake, you can see that it's liquidy. Okay? So I'm going to go ahead and add a little bit of manganese. And again, you do not have to add very much to this. This is about 10 grams of material, and I'm just going to add a small pinch. And by small, I mean small. Now my kids would put a whole scoopula in there. So I have to show them that not to put so much in there. And I'm just going to tip that in there. And now this is where you need the crucible tongs for, because I want to make sure this gets mixed in with my glass. Now you really can't tell from looking at it at this point that it's done anything to the glass, because it's red hot, so we have no idea at this point what the color is going to be, and neither will your students. Okay. Now I have a wire gauze with a ceramic center. Okay. And I'm going to pour the glass, the molten glass, onto the center, trying to make some beads, different shapes, and so forth. So I'm going to turn the burner off because it's plenty hot. Okay. And I'm just going to very carefully try not to touch the iron ring with your back of your hand. Oh, this is nice. Look at those. Those are very good. Oops, got a big glob there, but those are nice round drops. Those are going to be excellent when they cool. Okay. So put that back up. All right. So looking at a periodic table, what I would do with my students, and again, where would you teach this? Lots of places. Physical and chemical changes. You're making glass. Now remember, glass is not really a crystalline substance. It's molten amorphous. Yeah, so it's an unusual material, but it's very common. I mean, everybody knows what glass is, but there are many different kinds of glass. So you have to explain to the kids, well, what kind of glass do you think a evaporating dish is, or a watch glass is, or the glass that's in your windshield in your car, and so forth. And so they can come up with quite a list of different types of glass. And I said, and I'll ask them, well, can you color the glass? Yes, we can color the glass. How can we make colored glass? Well, how we make colored glass is we use some of the elements off of the periodic table. Now, by this time, my students will have learned the names and symbols. And so I said, well, let's go back and take a look at what elements we've used so far in the making of the glass itself. So we have manganese, which I just made. We have some iron, we have some cobalt, we have some copper, and we have some chromium. So we have those 5 elements. We have lead, but the lead glass, if you remember the sample that I showed you, it was relatively clear. So lead, which is down over here, does not seem to have any colorant effect on the glass. So I'll ask them, well, what kinds of elements are these here? Their first answer might be metals. And I said, all right, what kinds of metals are they? And hopefully someone will remember that they're transition metals. And if we've done things with electrons and orbital diagrams, I'll have them get these out, and I'll give them the charges on those ions. And I'll let them put the electrons in the orbital diagrams and ask them, well, do you see any commonalities? Do you see any differences? And again, trying to draw them out, and those would all be lab questions if I were doing a lab, or if I was doing this as a demonstration, I would include those as part of the demonstration. All right? So, again, making glass is, if they're into art at all, is something that you're going to have some students that from that day forward are going to love chemistry, because now they see a relationship between the art and the chemistry. And the last thing I want to do is let's take a look at this glass. It's still a little warm probably. I don't want to pick it up just yet, but I'll bring the plain glass over to it, and you can see that the manganese did color it. And if I bring the iron over, I've made a different color again. And when this cools, it'll deepen, and it might even be a little darker. Thank you.